Thank you, Chair, and let me be very much thankful to INSA for giving me an opportunity. I feel that I am an odd man out here because I happen to be a technocrat among the august audience of really stalwarts in India, scientists basically, but I happen to be a technocrat doing a lot of work in the ocean, basically to develop technologies. So right now, as mentioned, I am at IIT Madras. Let me thank all my colleagues at NIOT. The work which I am going to say is the effort of so many people, hundreds of technologists in NIOT. I'm just going to just tell you in the next 20 minutes. Let me just introduce and let me go through some of the measuring platforms in the ocean, the moored buoys, then the drifters before concluding. So I don't have to explain to this August audience IPCC for 1.5 degrees centigrade. All these things are very well known because we are not a real elite scientists of the country. But just we see that the ocean is the real sink of the carbon dioxide, and even it dominates in the Earth's carbon cycle, and the productivity also takes place in the the surface of the ocean. So really ocean is the important thing. What I find is that unfortunately we know more about the Mars and the moon rather than the ocean, which is quite close to us. Even if you ask people in Goa how much you know about the ocean here, it will be very, very less. But you know about Chandrayaan 2, 3 and whatever it is. Unfortunate, it is very unfortunate because okay, it's not that we should not go to Chandrayaan, but we should know first about the ocean, which is really giving us life. So you see that where are we? I mean, the atmosphere takes only 2.3%, but the ocean is really taking such a large value of 93.4%. So the reanalysis has been done, and you can see the data here. And if you see, the ocean, sorry, the earth is suffering. Like when we have the issue with the human body, we go to the doctor, he says you have to do so many tests, analysis, etc. With the advent of technology, so many are there. But what do you know about the earth, so to say? Land based, we have heard a lot of presentations. But the ocean observations, if you see, I'm not reading out or talking about what is exactly written here. The point is that we should know what exactly is happening. To know what exactly is happening, we need lots of observation sensors, etc. in the ocean. We have many, but still it is not adequate as we can see. So what we need? We need various types of observation. One type is moored, which is stationary in the ocean, and we measure the parameters, both subsurface as well as in the surface. But there are other ones which can move, like for example, they are called Lagrangian floats, which move along with the current and the waves, etc., and measure the parameters. So I will just now quickly go through all of them, but within these 20 minutes, quite difficult for me to explain everything, but I will try to see what is best possible. Now, if you see the Indian context, perhaps all of you realize that the weather prediction in the country has improved from what it was about some 20 years back. One of the important factors to this is that we have got a lot of observations from the ocean right now, which is getting into the models of IMD and INCOIS and other institutes from where the prediction has improved. Cyclone prediction, you see that quite accurate in space and time is possible, and the life which is lost is quite reduced. That's basically because of the observations. And what are the observations is they could have lot of hits of instruments in that which really measure online the parameters which are basically like air, water temperature, atmospheric pressure, salinity, water quality, wave, data, wind gust, all these things are measured on a real-time basis. Now the data buoys are basically something like this. You can see that they are all located at various locations in the Indian waters. AD is all for Arabian Sea, and the other ones are from the Bay of Bengal. It is something like this. They are floating in the water, and you see that Okay, I will show it here. You can see these buoys are somewhere like this, and it is floating, and you can through satellite. It comes to the Earth station. It comes to NIOT, and you can see that these are some of the cyclone paths which has been traced out by the various data buoys in the ocean, and the ocean observation systems was established in 1997 at NIOT, and from there onwards we get lot of data online, and we can see that there are about 318 more observatories globally, but we have much more. I mean, we have got all this data available in this GPS format for all the countries, so to say, because it's a shared data. It is for common mankind. So this is how the mooring system will be. It could be either a taut one, which is directly moved on the seabed, or with a slack one, which is an inverted catenary, it is called, with this polypropylene rope, and this would really have various applications. For example, the taut one has got a problem that it may just move along, where in case of a cyclone, this called mooring walking happens. But instead of that, we normally do it in India with a slack mooring. You can see that it's something like this. You can see the various sensors which are there are put on the mooring line. You can see the CT, that is the conductivity, temperature, CTD, all are put here. And there is something called induction mooring. Induction mooring means the data is transmitted through induction into this mooring, and it comes to the surface where there is a data acquisition system, and from there it is transmitted to the Earth station at NIOT, from where it is disseminated to INCOIS, who are the custodian of all the ocean data in the country. And of course, this is how the surface portion is shown here. You can see the humidity sensor and others. We also have it not only in the deep ocean, but we also have in the coastal region. Coastal region mooring is quite challenging because you have got a lot of corals, etc. This is a picture of the one which is in Andamans, which is set up in Andamans. Now, if you see, this is how the cyclone, one of the cyclones, Pilani, I think it has been tracked, and you can see that the wind speed and the air pressure. You know, the wind speed has suddenly clogged up in this region, and the air pressure has come down. The various locations which has been measured, and there is also a means wherein we have a system where we have higher data acquisition that is happening exactly when the cyclone passes over a data point. So all these things have helped in predicting the cyclone track accurately. Now, there are issues. When we have all these things in the ocean, we know that either human or natural, because of which these are being damaged. So this may be the fishermen, when they come and connect to these things which are in the deep sea, and in case of any, the net will get entangled, and they get into lot of issues, and they damage the buoys. So this has been going on. Let me also tell you that one of the hotspots of that is Goa. So perhaps some of you, when you are landing in the aircraft, you can see that there is an island there. You can see this picture also there. So this is the region where always, that is consistently the same location this happens. So we have again done some indigenization or ingenious method wherein we have put 3 cameras there, and we call it as Argus, where we just monitor it because it's close by, so we can even do the data transfer through our normal 3G or 5G. So this is set up in this location to identify some of these people who take it off. Now we also have, that tsunami is another important issue which really we have to work on. So what basically happens, we all know that the tectonic plate movement, etc. is well known. So what is done is, the pressure is measured, the change in pressure that's happening at that particular instant is measured using the bottom pressure recorder, and that is acoustically transmitted to the surface buoy, and it goes to NIOT and INCOIS, where algorithms say that whether this will cause a tsunami or not. And this is a very important one because this particular measurement has to take place at a depth of say some 4,000 meters, that means 100 bar pressure. We have a few millibars of pressure movement due to the water level variation. So the only sensor that is possible to measure this is a quartz crystal, where you know that we have the quartz crystal which is working at a particular frequency, high frequency, and in the axis which is perpendicular to that, you get the variation of the pressure, and you can find out the change in the frequency and measure the water level variation. So this is also compensated by to temperature. So this is the one which is actually put by all countries, including Japan, which is really sitting on a plate. So this is set up at various locations as I have shown you. So the data will come to, of course, it comes to NIOT and also to the service provider to invoice, and they give the warning. Perhaps if you go to the website of invoice, you can find out that any moment in time whether a tsunami will occur or not is given by that. Now, this is a particular observation which occurred some time back in 2013 in southwest of Pakistan, and you can see the magnitude and the depth, etc. And it picked up the the pressure variation. As you can see that when such a pressure variation occurs, the data acquisition is done at a faster rate, and you can see that this is the the tsunami buoy which picked up the data, and these are some of the data that has been plotted for that particular condition. And this is the way in which the tsunami is measured. Now, there is another aspect that the Arctic, the warming and everything what is happening there. There is a teleconnection, is there or not, between Arctic and Indian monsoon. So to study this, with NCPOR Goa here and Norwegian Institute, we have developed a buoy which is deployed in that particular location, Kamchuran Fjord it is, and there we have got the moved observatory with any of the sensors put there, and you can see that this is how it is done there. You can see this is the buoy with the suite of sensors. Some of the data, results data we analyzed, we have shown here. And you see that this buoy is completely underwater because you cannot transmit online because most of the time it is covered with ice. So the transmitter there will get damaged. So it has to be completely underwater. So the only problem is that every year one has to go there and pick it up. That is the issue there. But that is being done by the team even now. Now, there are so many other platforms. There is something called Data Buy Cooperation Panel, in which all the data is being transmitted to all the countries as I told. So these are the, this is actually taken from the web. You can see the various countries and which are the, which are the data buoys available. It will be drifting buoys, it will be mode buoys, etc. And this shows the latest one as last month. And if you see that, lot of data is there from various locations, various devices. As you can see that, I will just go through these systems just quickly so that you get an idea about that. One is Argo Float. Argo Float is given by the name of the Argo satellite, but Indian one also can be used. Unfortunately, ISRO has still not given a satellite for use for these purposes. So we have to depend on Argo, which is a foreign satellite. And you see that this has got a variable buoyancy engine. Just a simple Archimedes principle is used for this to go up and down. There is a bellow here, which oil is filled in and taken out, and it goes up and down, and the data is collected, and it is transmitted when it comes to the surface to through the Argo satellite to India. Now you see the Indian Argo program started quite long back. The idea is to have in the 3x3 latitude longitude area to have one of them, one Argo flow. So a lot of data is collected from the various locations in this, and you see that next one is a glider, which really does not require any power for its locomotion. It goes by the drift and the drag and the lift principle. And this is also developed. This is also being used by India to collect data at various locations. And you see, this is a list of all of them. This is really quite large. I may not be able to go into detail about each of them. You can see the Argo, drifters, etc. I told the drifter can just drift along with the current. Then we have got current meters connected to the buoy again to measure current. Then we have got CTD, that's connectivity temperature depth by putting from the ships. Then we have HF radar. I will just explain that in a minute. Then of course all these things are quite in various locations available. I want to explain about little bit about this HF radar. Actually, there are only two people in India who are working. One is sitting here, Dr. Shankar, and another is Dr. Jena in NIOT Goa, who are working in this HF radar data. Here we have one transmitter and a receiver. As you can see here, the locations are shown here in this map, and you get the data in a complete area, so to say. That is, if you see here, you can see that in an area up to about 200 kilometers, you get the current not like a point one with as a vector. That is, you can get the direction as well as the magnitude. So this is done in various locations, but still it is not complete in India. Countries like US has got it in throughout their coastal region, but unfortunately due to the prohibitive cost, we have still not done it in everywhere in India. Of course, we have the various other programs as part of the Deep Ocean Mission, which is coming up. We have got a deep Argo floats to go up to more than 2,000 meters. Then we have various campaigns there. There is Arabian Sea Field campaign, many campaigns with both collaboration with Scripps, Woodsole and other institutes, as well as our Indian institutes. So this has been already explained in detail, so I'm not going to explain about this. Space-based ocean observations, so many are there. OceanSat, Megatropics, all these things are Indian satellites from which you can measure the wave characteristics, the ocean color, all these things are possible. I will just like to conclude that it is necessary to expand this. Earth is really not adequately monitored till now, so we need to really have more observations, and India has to follow suit. And any other coastal erosion, beach restoration, all these things need data on a large scale. So this is really essential, and predictions, it requires more data, and the main last thing is more important because we need a large number of trained manpower to be deployed for this. People are not fully aware of this. Everybody knows about space, but very little knowledge about the ocean is there, unfortunately. Thank you very much once again. Thank you.
I have a question about international waters. So, if India wants to put buoys outside its territorial waters, how does any country go around doing that? Or do we have to cooperate, because sometimes waters do not belong to that particular country? How do we deal with that situation?
If you want to put a buoy outside the EEZ, that is normally called as common heritage of mankind. It doesn't belong to anybody but belongs to everybody. The only issue is that the data collected there should be shared in the GTS format as part of this DBCP, Data for Cooperation Panel. So data should be available for all countries. You should not say that I will put a buoy and I only will use the data. That is not allowed. See, this is the international cooperation. So it is allowed to be used. And if you want to put it inside our EEZ, you have to take clearance from our Indian Navy, and there are some restrictions because the temperature data is very sensitive. They don't allow the temperature data to be transmitted online because the acoustic, the speed of sound in water is dependent upon temperature. And that is a very important aspect when they talk about sonars and other things. So they really have a restriction for that. Otherwise, international waters, it's fine.
Very simple question. Boy, how you enter this ocean? Otherwise, you will not move this thing.
We have a dead weight for that. There will be a dead weight which is put on the seabed, and from there you take a slack mooring. I mean, it is connected.
That means you cannot put in the middle of the ocean.
Yes, it is in the mid sea.
How long is it?
It is about 3-4 kilometers, the length of the mooring. Yes.
This is a quick question since you mentioned in the last lecture also it was clear that we need really a good manpower sustainable for a long time. Are there any serious programs to collaborate and use the universities which are away from the coast, which are running? I'm from university, there are very few from universities here. We do conventional physics, chemistry, mathematics, even ecology. Are there any programs to outreach such universities and draw them into these exciting areas?
Unfortunately, I should say, my limited knowledge, no. But
That is your answer.
we really should do that. I fully agree with you. We should do that. IIT Bhubaneswar, sir is from there. So IIT Bhubaneswar has been doing something, but not enough, I should say.
Permit me to interfere. Everyone focuses, I'm sorry to say, on national institutes, IITs, and at best, some central universities. Huge manpower is available at universities which is not being trained. It's not that they are not trainable, but everyone thinks that the research comes only from top level institutes. That is absolutely wrong. So, should go and talk to the universities, induce them. I know what we are, but still you have to.
Yes.
When we come closer to the undergraduate colleges where we have to try explore.
Sure. I mean including undergraduates.
Absolutely. Undergraduates.
Absolutely.
But let me also just tell you the other side. That the thing is, regular manpower takers in India for this are less. They can take, like I know when I was sitting on the other side, the government provides enough money, but not regular manpower. They say that you take manpower on a contract basis. See, the contract manpower, they cannot do this type of work for a long time.
I completely echo his sentiments. The biggest challenge for all of you at the Indian Academy of Sciences to hand holding with great urgency with the academic.
Yes.
Sir, can I make one quick comment on this particular on this particular aspect? So involving universities, in monsoon missions, I am from IIT in Pune. So there is a recent recent approval from Minister of side, where it is categorically told that extramural fund will be given to universities. Okay, data also will be given from IIT, computer also will be given by IIT, and universities will be given this charge and students and faculty to do analysis for their respective region. So one university from Assam, Tripura, and everywhere, and faculties are joined, couple of universities, and data will be shared. Computer also will be shared, HPC, and intramural funding, JRS salary will be shared, and to take them on board.
I just end with one thing. The only point is you end with JRF, SRF, and project. That's not what is required. Real one person who is working with a salary on a continuous basis. Sorry, I'm taking more time. Thank you.